on the topic of bootstrapping using technology for estimate. Let us begin by a simple definition. Given a simple random sample of size n, a bootstrap sample is another random sample of n values that is obtained with replacement from the original sample. Please note that without replacement, every sample would be identical to the original sample. So basically the proportions, the means, standard deviance, and variances would be all the same. And there would be no confidence interval to work with. So again, please note that a bootstrap sample involves sampling with replacement so that when a sample value is selected, it is replaced before the next selection is made. What are the advantages and disadvantages of bootstrapping method? Bootstrap resampling gives us a reasonable estimate of how the point estimate of the parameter changes. With enough bootstrap samples, the resulting distribution of the sample statistic tend to be a reasonable approximation of the true distribution. Be careful about disadvantage of bootstrapping. It should be noted that with bootstrap method, many samples are basically generated, and those samples are then used to generate the statistic being used to estimate population parameter. The sampling distribution of those statistics is centered around the sample statistic of the original sample data, not the population parameter being estimated. So if we have a sample with a point estimate that is very poor estimate of population parameter, the bootstrap method will not make that point estimate any better. So be careful about the disadvantage of bootstrapping method. Let us take a look at one example. Bootstrap sample of incomes. Suppose we collected the annual income of current statistics students. The original data are 0, 2, 3, and 7. The bootstrap sample can be 7, 2, 2, 3. So selection with replacement. The sample of 7, 2, 2, 3 is one bootstrap sample obtained from the original sample. Other bootstrap samples may be different. Remember that incomes tend to have distributions that are skewed instead of being normal. So we shouldn't use the methods with a small sample of incomes. This is a situation in which the bootstrap method comes to the rescue. So bootstrap method from data science point of view using Python. A data scientist is using the data in a random sample to estimate an unknown parameter. She uses the sample to calculate the value of a statistic that she will use as her estimate. Once she has calculated the observed value of her statistic, she could just present it as her estimate and go on her merry way. But she's a data scientist. She knows that her random sample is just one numerous possible random samples, and so her estimate is just one of those possible estimates. Well, by how much could those estimates vary? To answer this question, it appears as though she needs to draw another sample from the population and compute a new estimate based on the new sample. But she doesn't have the resources to go back to the population and draw another sample. It looks as though the data scientist is stuck. So what's the solution here? What should she do? Fortunately, a brilliant idea called the bootstrap can help her out, since it's not possible to generate new samples from the population. The bootstrap generates new random samples by a method called resampling. The new samples are drawn at random from the original sample. In this section, we're going to see how and why the bootstrap works. And in the rest of the chapter, we're going to use the bootstrap for inferences. Now let us take a look at the employee compensation in the city of San Francisco. San Francisco Open Data is a website where the city and county of San Francisco make some of their data publicly available. One of the data set contains compensation data for employees of the city. These include medical professionals at city-run hospitals, police officers, firefighters, and so on. Let's take a look at the compensation data for the calendar year of 2019 that are stored in table SF 2019. Let us read the table and then take a look at the first three data sets. As you can see, you have different categories: organization group, the department, job family, job, salary, overtime, benefits, and total compensation. There is one row for each of over 44,500 employees, and there are numerous columns containing information about city departmental affiliations and details of the different parts of the employee's compensation. Very good. Let us take a look at the row corresponding to London Breed, the mayor of San Francisco in 2019. The where method is going to be used to filter rows in the table based on specific conditions. In this case, it filters rows where the specified column, which is our job column, matches a particular value, which is the mayor. Basically, where job, comma, mayor applies a condition to check each row in the job column. If the value in that row is mayor, it includes the row in the filtered result. So as you can see, here we have the row returning all the values for the mayor. We're going to study the final column, total compensation. That's the employee's salary plus the city's contribution toward their retirement and benefit plans. Financial packages in a calendar year can sometimes be hard to understand as they depend on the date of hire, where the employee is changing jobs within the city, and so on. For example, the lowest value in the total compensation column look a little bit strange. So as you can see here, you have some jobs and the salary is 0, overtime is 0, benefit is 0. And we don't get any meaningful information here. Remember that the sort method orders the rows of the table based on the values in a specified column, which in this case is total compensation column. For clarity of interpretation, we'll focus our attention on those who had roughly the equivalent of a half-time job or more for the whole year, at a minimum wage of about $15 per hour and 20 hours per week for 52 weeks. That's a salary of over $15,000. So we're going to use the where method to filter rows in the table based on a specific criteria. In this case, it's being used to keep only the rows where the salary meets a certain condition or above $15,000. Then we're going to return the number of rows in the San Francisco 2019 table after the filter that is applied. So basically we have 37,103. In this case, the output is 37,103, meaning that 37,103 employees met the criteria of earning more than 15,000 in 2019. For the population and parameter, let the table of just over 37,000 rows be our population. We're going to create a histogram of the total compensation for the employees in this table. So let us run our code. As you remember, we're going to use NumPy arrange that creates an array of values ranging from 0 to 726,000 in increments of 25,000. This array defines the bin or intervals used in your histogram. Remember that the range up to 726,000 is chosen to include the entire range of total compensation values. And remember that the highest compensation that we saw was $700,000. Very good. So let us take a look at our histogram. And histogram only use the total compensation. On the horizontal line and on the vertical line, we have the percent per unit. As you can see, most of the values are below $300,000. A few are quite a bit higher. For example, total compensation of the chief investment officer was over $700,000. That's why the horizontal axis stretched toward the right-hand side, and you can see you have $700,000 on the right side, and the data is skewed to the right side. Usually the